Hello everybody, today we're going to talk about the Taylor series and some easy steps in solving them. So let's first take a look at what the Taylor series is. So we have the sum, starting at 0, of f of n at a all over n factorial times x minus a to the nth power. This term-wise looks like f to the n of a all over n factorial multiplied by our x minus a to the n, and then this will keep going forever, but we're going to show you what this looks like in an actual example. So first, let's go over the steps. These are 4 steps to make these problems really easy. Just go one by one. So steps in solving. So the first step is you need to write out our table. So write out table. Now what is the table? So every single time you do these problems, we need to set up an n, f of n, and this is at x, and then an f of n at a. It's going to look like this. So every single time we do these, you're going to, depending on how many terms you want for your answer, I usually start at 0, we'll go to 1, 2, and 3 typically, so 4 terms. The 0, n at 0 just means simply f of x. Next one is f prime at x, then I'll go f double prime, and so on and so forth. So when you set this up, just know that this 0 means your original f of x. 1 is f prime, 2, f double prime, and so on. So your original problem is going to go right here. So your original problem. All right, a will be given in the problem. So what you'll do is you'll write out your original problem. Anywhere you see the term x is where you're going to plug in this. So if we had a equals 1, I'm going to plug in a 1 everywhere I see x from the original problem. This will get you a number, and then this number will be very important. So during this, the only numbers that we'll need to build our Taylor series will be these numbers for the n, and then these numbers, which are your answers from your table. Step 2. Is this a Taylor series or is this a Maclaurin series? There is a difference. I will have another video explaining the difference between these, but simply, Taylor series is anything that does not have the center at 0. So this, a equaling 1, would be a Taylor series. Anything that a equaling 0, or if it's not stated, we assume it's at 0, is a Maclaurin series. 3. You're going to plug in to equation. So all this simply means is once you get these answers, like I said, n over here, and then your answers, we're going to go ahead and plug into this, which I'll show you in the example to come. And final step is to simplify. Simplify. All right, let's just jump right into our first example. Okay, so here we're going to do number 7 from section 1110. So our f of x is the cubic root of x, and we have a at 8. So this tells me this is a Taylor series. So we don't need to worry about the Maclaurin series. I have my table built already. So n, I put my 0 through 3. So we're just doing 4 terms here. Remember, this is f of x, f prime of x. So we're taking the derivative as we go down the table. So my original problem, I'm going to say that this is x to the 1/3. It just makes it easier to plug in numbers. So this is always your original problem. All right, now right here I left it empty. This is where a goes. In this case, we have 8. So everywhere we see an x, we're going to be plugging in 8. So this simply means 8 to the 1/3 power. This will get us 2. All right, moving on, we're going to take the derivative as we go down. So that's what the f prime of x is. So n at 1. So I'm going to multiply this forward. So we're going to have a 1/3 x, and then if you need to do on the side, we'll go up here. We'll say we have a 1/3 derivative is minus 1, but because we have 3, I'm going to go minus 3 over 3. So we have a negative 2/3. Let's go over here. Our x stays the same. X times our 1/3. And then this is to a negative 2/3. Here you will want to use a calculator, and I have already done it. So we have 0.083. All right, and then you're just going to continue this process, taking the derivative every time we go down. So let's just go ahead and do that. Negative 2/9, and that is a 2. We have x to a negative 5/3. So I have it negative 2/9 multiplied by the 8. And this will get us a negative 0.00694 repeating. All right, one more to go. Multiply it straight down. We have a 10 or 27. And then we have a negative 8/3. All right, copy right over. So 10 to 27 multiplied by 8 to a negative 8/3. Okay, so these are the first 4 terms. So now all we are interested in are these numbers and these numbers. Okay, so plugging into our original. So right here, we have the setup of how this problem is going to go. So all we're going to do is simply plug in what we know. And we're not going to be guessing here, we're literally just filling in. So this is something that you can memorize, or you can just write it on a flashcard every time you do these problems. Taylor series is always the same. So we have our first number, so it's f at our a, so we have 8, and that's going to be multiplied by our 2. So in this case, we are going to have 2. Oh, excuse me, sorry. So the 8 is not yet that, so that's what we multiplied at. So this is f at 8. So we're looking at the first term. So first term and first term. So what we're doing is 2, which is our first f at 8, and that's going to be multiplied by our x minus 8, and this is to the 0th power since we're working with 0 right now. So essentially we're just going straight across. And this is going to be over the same n, which is 0 factorial, moving on to the next term. So that one's done. Now we're on the second one. So our number is 0.083. That's going to be multiplied by our x minus 8. Now we're moving up to the first power. And then this will be 1 factorial. Now, these two are not required. They obviously will go away, but if you do want to write those out, it can help to visualize this problem a little bit. Moving on to our third term, we have a negative 0.00694 repeating. X minus 8. Now, this is to the second power. This is all going to be over 2 factorial. So there is a pattern with these. I'm not going to write up the third one since you can probably imagine what it's going to be. So just keep doing this all the way through. When going to simplify these problems, they're pretty much simplified. Just know that this will go to a 1. 2 factorial is obviously 2 times 1, so that's 2. So we have 2 factorial is 2 times 1, which is 2. 3 factorial can be simplified as 3 times 2 times 1. Which in this case is 6, and you'll just continue this pattern all the way through. And then once that's fully simplified, this is your answer. So I hope this helps in seeing the Taylor series. Setting up this table will really help organize your work. Just be careful that you are going straight across when plugging in your numbers. Remember, your first number you're plugging in is this side. Then you're plugging in whatever nth term you are using. All right, until next time, guys. Thank you.